All right, in this episode, we'll be doing the double linked list. So, in the last episode, we did the single linked list. In the second episode, we're going to do the double linked list. So, let's just first create a node. And so, the basic steps are pretty simple, exactly the same. The first thing that we are going to do is create the node and then insert at the beginning, insert at the end, delete node, search, traverse backward. Traverse backward is going to be a new thing that we're going to do in the double linked list. And traverse forward, obviously, because we will have both side traverse because it's just a double linked list. Rest of the things are going to be very much the same. But let's just do this real quick. All right, so the first thing that we obviously are going to do is create a node, and inside the node we're going to have the next self data, next, and previous, right? Then what we're going to do is just create a class calling it double linked list, right? So basically we're going to have a linked list and a node as always. Then we need to initialize this class. Self.head is equal to none, right? And then we're going to do our first function, which is going to be insert at the beginning. So in using this function, we are going to insert the node in the beginning of the double linked list. So how do we actually do that? By creating a new variable, which is going to be called as, which will add a data into the node, right? And the new node dot next is equal to be our self.head. If self.head.previous is equal to no, is if your self.head is not none, then self.head.previous is going to be the new node. Self.head is equal to new node, then print data at the beginning. That's pretty perfect data inserted at the beginning. Okay. All right. I think, yeah, it's perfect spelling. No spelling mistakes this time. Now insert at the end. So we did the insert at the beginning, and now we're going to do insert at the end. It's kind of pretty similar, not exactly, but in a way similar to the thing that we have done before, like single linked list. It's kind of pretty much similar to the last one that we have done. Let's fast forward this by a little bit. So my last node is going to be pretty simple, and obviously you are going to find the entire source code in the description. And also you'll get the explanation of the steps in the description so that you can obviously have some kind of resource that you can look into for the understandings, and also the definition of this so-called our linked list. Mm. Right, so it will say that the data is inserted at the end. So now data is inserted at the end, so now delete node. So the first thing that we do is insert the data at the beginning, then we do at the end, and then we do the deletion of the node. So deletion of the nodes is exactly the same as it was in for our singly linked list. It's nothing different than that. Nothing different. Almost the same. In most cases, it's exactly the same. Linked lists are pretty much exactly the same, three of them. But the basic difference is the method of insertions, and deletions is pretty much the same, and even the traverse I should say, is pretty a little bit different, because in the circular linked list you genuinely have like two different traverses. Even in the double linked list you have two different traverses. But the main component difference is basically, okay, double and circular linked list are pretty much the same. Single linked list is easier, and these two are a little bit difficult. Like if in case you are measuring this with a scale, it's a little bit difficult than the single linked list. All right, because the deletion of the node is pretty much different. then the single linked list. Okay, current is not none. Okay, if current is not none, then do this. Key is not found. Okay. All right. So current is previous is not found. Is not okay. Agar if current dot previous is not none, then the current of the previous dot next will be the current dot next, and then the current will be none. That's it. We're going exactly the same, and then we'll just say that we have successfully deleted our key provided. Right now we're gonna do the search. Search is going to be basically searching some kind of key element out of the entire uh, linked list and return us the index that this is the place where it is present. Okay. First of all, we are going to check the current data. If it's on the current data, then it will just going to return the current data. If it's not, then we are going to perform the search. We are going to do like all the stuff, all the work in the world we're going to do to find out where exactly does it exist. And it's pretty simple. You have to just go next, 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 because the current is starts from the head, right? And if you don't find it at the head, at least you'll find it at the tail. So you go on the single direction 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whatever the height or whatever the size of that double linked list happens to be. If you're searching from backwards, then you go on minus index. But in here case, we're going from the head to tail. So if you're going from tail to head, minus, minus, minus. In this case, plus, plus, plus. Next, next, next. Simple as that. So search is not hard. If you're doing in circular linked list, I guess it's kind of pretty much complicated than this one. So as you can see, as I told you, traverse forward and traverse backward, two different things. We want to start from backwards, from the tail to head, then traverse backward. And if you want to start from forward, head to tail, then the first one. That's how it goes. Okay. Once you start implementing them by your own self once, twice, and once you start to really read the code, not just copy paste the code, read the code and start to just analyze the code, it's kind of interestingly easier. It seems too complicated, but it's kind of really easy. It isn't as difficult as it seems. It is really easy once you start actually implementing them in your head. Once you start implementing them in your head, a lot of significant of times I usually do that. I usually find it really difficult to sometimes even write the code. But once you understand the concept, once you understand like how these things are happening, it's really easy to leverage AI. It's really easy to leverage the black box code, black box AI to just come up with the code once you understand how these things actually work. And once you understand how these things work, you just have to go with it. And that's what we're going to do in the further episodes of this courses. First 50 days will be dedicated to learning different data structures. And then next 50 days will be dedicated to learning how to implement them into real life. What kind of interview questions are being asked in the interviews, like the real world interviews, the job interviews. We're going to dedicate those 50 days towards that. So we're done with every single thing you can just see on the screen. Let's just run this program and you can see our perfect output. Inserted, oh fuck, inserted, traverse and deleted, and again traverse, and that's perfect. Search is also working. Everything is working exactly as it is supposed to be. So see you in the next one with circular linked list. Till then, keep watching. Code Red.